Next question is no, this. Okay, so we have done that this one. So yeah, next question. This is about genetic correlation. So although we didn't really mention genetic correlation, but in the simulation we can have a briefly look how to simulate the two correlate traits. Then let's have some practical on that. So first we look at the VG dash sim2, and this is very similar to the single trait. Only difference is now number of trait is assigned as 2 here, now 2 trait. Then the mean is the same as 0 as before, and genetic variance for the so in this case this is a second trait. So first trait we assign as 5 and 5 for the genetic variance and 12 for the residual variance. Now for the second trait we give a genetic variance is 200 and residual variance is 500. Then the correlation between first trait and second trait. So in this case, actually genetic correlation, and probably residual correlation is 0 according to here. I will show in the next few lines. So uh, this function a bit complicated, but this basically saying that this is the first genetic variance, and this is correlation times square root of genetic variance for the first trait and second trait. It means this is genetic covariance, and this is same as this one, and this is second genetic variance, right? So this is basically shows. I will probably give sorry, I'd like to find my whiteboard. So yeah, here. So I can briefly draw what does the structure look like. So first I will delete this one. So the line basically has a 2 by 2 structure, genetic variance covariance structure. So this is the first trait, this is the second trait, and this is the first trait, and this is the second trait. Then the code actually specify the genetic variance for the first trait here, and genetic variance for the second trait here, and this is the genetic covariance, and this is the same. There is a symmetric variance covariance structure. So this is the same as this one, this one. Okay, so this code basically specify the structure that I show here. So in this case, the correlation times square root of the first trait and second trait for genetic variance is actually genetic covariance. Okay, so this variance covariance structure is stored in GMAT, that is genetic structure matrix. And how do I simulate genetic value? I use now multivariate normal distribution. So using 10,000 record as before, and using mean as 0, and using the structure specified here, right? Then it will give a multivariate normal distribution for that genetic value. Then residual value here is the same as actually before in the single trait, that means there is no covariance structure. Okay, then phenotype, this is simulated as before. The phenotype is genetic value plus residual values. Okay, then let's run this code. So using same source and second tree. Okay. Yeah. So as you can see here, this YV is not single vector. This is a kind of matrix. That is a number of records by 2. That is the first trait and second trait. So there is a correlation between the first trait and second trait for the phenotypes. And this is a correlation between the first trait and second trait for genetic value, right? So in this code, it shows the phenotypic correlation is 0.1 and genetic correlation is 0.3. So, so this is the answer for the question. So what is phenotypic variance structure? And what is genetic covariance structure? And what is expected genetic correlation? And what is observed genetic correlation? So you can also have a look from the actual value. So this is a function that give structure for the value. So that is something like this. So this is a phenotypic variance structure, right? This is the genetic variance plus residual variance for the first trait, and this is the for the second trait, and this is covariance. So, and what is genetic structure? That is GV. So this is the genetic variance for the first trait. This is genetic variance for the second trait, and this is genetic covariance. So you can probably you can check whether according to this code whether that is agree with this observation or not. So what is expected genetic correlations? So because you simulated the true simulated value is 0.3, right? So expected genetic correlation is 0.3. This is for genetic correlation that you simulated, right? So this is 0.3. Then what is observed genetic correlation from the data? So this is around 0.32. It's quite close, right? Close, but also it's in the same principle. So that depending on this number of records. If this number of records is very small, then this difference can be large. But if this record is getting large, then expectation observation is getting close.